All right, guys, welcome to the BioGym webinar today. First of all, a little bit of a sound check. Can you guys see and hear me properly? Maybe just give me a thumbs up in the chat. Very good. So let me close the chat window again because that overlaps with your screen. And let me also switch off the video. Right, so thanks for joining. Thanks for registering for the webinar. We'll do roughly 55 minutes on geoBIM.app, more a walkthrough introduction than showing a lot of use cases, so it will be quite functional. As always, a couple of slides in the beginning. My name is Christoph, background civil and structural engineering, been with a couple of companies. The latest one was Bentley Systems, where I picked up the cesium technology. Couple of others as well, but basically at Bentley Systems, when they acquired Cesium, I came in contact with Cesium. So the basic motivation to create an application like this was to sort of bring the building information modeling and the geospatial world closer together. Because I think we all understand there's enough, let's say, authoring tools out there like Revit, ArchiCAD, MicroStation that are great in design and creating models. But are usually desktop, and then when it comes to just bringing it together with geospatial context, you can probably read in digital terrain models into the CAD application. But in kind of publishing it, then you have on the other side, companies like Esri doing a great job in providing map data and terrain data, and somehow I just missed the application that brings two worlds together without just being another BIM viewer or just being another GIS viewer. And in the end, that should break discipline silos that we all know still exist. So I thought about how about creating a pragmatic solution for the architecture, engineering, construction, and operational community in the GIS domain. Basic thought was to give everybody full control about what they do, and I think very important these days is secure data and code sovereignty. So having it run on-prem on your own data center was key. So my advanced thoughts on creating this was okay, I came in contact with Cesium JavaScript libraries, so we keep it web native. Let's keep it open technology and architecture, so everybody can link their data sources to it. Use established world-class technology as there is in the CesiumJS, which to 95% probably is open source and can be used free of charge. Do not create another just BIM viewer. There's tons out there using 3GS or Rust or whatever, or GIS viewer. But create something new and which fulfills in a pragmatic sense the demand of the engineering world. We all know that when using IFC files, which are not meant for streaming, we need more performance in streaming large models. We need flexibility to have data from various sources, and it needs to scale. So it doesn't matter how many people are looking at the same model. Another thought was it should be easy to customize and deploy. It should be able to be run in the cloud, on a private cloud, or even on-prem. And then I thought sharing the code base on GitHub is a good thing, so everybody can do something with it. So I thought about making it completely open source. I decided against it, and I made it available for everybody under business source license 1.1, which basically means for non-commercial use, you can do anything you want to do. But for commercial use, you have to ask me. And I think I put in a time frame of 4 years, and then it automatically becomes MIT open source. Briefly, a couple of challenges in the AEC industry. There's usually a lack of context. There's a lack of georeferencing. You have multiple formats, multiple sources, multiple app workflows. And if you think about the GIS domain, you have QGIS, PDAL, DataSmith to handle data. And then, of course, you have operation and security and data sovereignty risks. You have to install something usually on-prem. Hosting is an issue. Operating systems are an issue. System requirements are an issue. Access management is an issue. And foremost, because I worked for this industry, you have a massive vendor lock-in if you commit to one of the larger corporations. I think that's all known, but these are the challenges. So what is geoBIM.app? First of all, it's a browser-native BIM GIS platform, which uses, to the most part, CesiumJS. I created a marketing claim, called it geospatial intelligence. It sounds pretty good, in my opinion. But I would probably call it more a Google Earth kind of application on steroids. Key features, or let's say key characteristics are you can load unlimited models. I mean, in terms of number of models and size of models. I think the only limit at this point is the VRAM memory of your graphic board. It can use IFC, Revit files, point clouds, reality data. Talk about that later. We have typical GIS formats like CityGML. We have terrain models. We have autophoto data, map data. And then potentially you can link any data source, because basically what geoBIM.app is, it's more or less a website consisting of HTML, JavaScript, and CSS. And then also, let's say the major use case clusters is, geoposition something, view something, of course, inspect, evaluate. So it's not only that it looks good, you can turn it a little bit, but you can also inspect the metadata, evaluate the metadata. You should be able to annotate and communicate and integrate the whole thing and collaborate with others. So as I mentioned, it's mainly based on CesiumJS. It's a browser native, 100% browser native platform. I'm using Firebase and Firestore as a backend to store data, metadata, presumably. The hosting currently works on Cesium Ion, which is very good in order to manage all the assets, because it gives you UIDs and it gives you a very good token management. You don't have to do that, but there's a freemium plan. It's not going to cost you anything. And it's pretty powerful already. You can choose a European web server, a European data center, of course. My website itself runs on my own data center here in Germany, but any asset server technically is possible. So there's no need or no must to run it on Cesium Ion. In terms of formats, you can basically geoBIM.app consumes all sorts of formats, foremost IFC, Revit files, GLTF, WMS services, 3D tiles, GeoJSON, and all that stuff that you probably already know. I mentioned the license, so it's not for free in the sense of you can make money with it, but it's all for free and on GitHub to create your own, kind of customized geobim.app out of this. Short explanation about the architecture of CesiumJS, and it's funny that an AI creates those typos in here. You won't get them away at that point, but you probably know what I mean. So the core of everything is the WGS 8.4 ellipsoid. And on top of that, Cesium creates a terrain provider, which usually comes with the Cesium World Terrain, but you can use any local terrain provider that you want from open data, whatever. And then on top of that, usually you have what we call image layers, which is usually a satellite kind of orthophoto picture or maps or WMS services. And then again, on top of that, there will be the 3D tiles, which are representing the buildings, the built environment, and so on. So it's a pretty straightforward kind of principle. Now it gets probably interesting for everybody who's a little bit more nerdy, the tiling pipeline. So on the left, you see all the data sources that geobim.app with the help of Cesium can consume. And of course, it's all the basic BIM formats. There's a direct plugin for Revit. You can import IFC, via iTwin. You can import microstation data, but also photogrammetric reconstruction data, terrain data, point clouds, and CityGML or any other GLB, GLTF model data can be filled into the pipeline, and then the magic happens, and Cesium will convert all those data formats and normalizes them, aggregates them into so-called 3D tiles. Think about a 3D tile like in gaming. It creates a mesh for each of those assets. But the nice thing about it is it keeps the metadata. So when converting Revit or IFC, it keeps all the properties, and there's also hierarchy. So for example, a 3D tile, a subtile that knows he's a window and I belong to a wall, that relationship sticks together. Okay, it stays together. And once the 3D tiling has happened, all the assets will be stored in a database. I use Cesium Ion out of convenience reasons. You can use any other database that you like to use. And it's not even a database necessarily, but it's a file server consisting of GeoJSON files and GLB files in a certain structure. So there's no need for relational database or anything else. It can be a plain file server to host all your data that you have converted. There is other design tilers out there from OpenShell that are able to convert IFC into GLB files, but then usually the metadata gets missing. And in some cases, you want to have that, and I'll show you later why. So once the assets are stored in the database, then the magic happens and geoBIM.app steps into place. And we like to create a front end where users can use those assets to create sceneries, position those assets on the globe, and investigate those assets. So that's basically the pipeline. Let me see key functionalities. I jump over that. I will share this PowerPoint slide deck or the slide deck later in the repository. Up there, there's a features MD file, which I usually update with all the current features in the current version. But usually it's BIM assets and all the functionalities around it, investigate the data then that you can do with the reality data. How can you collaborate, annotate, and share, light and shadow effects, what layers you can use, what data you can link to, and some other performance, let's say, related features. I'm not jumping too deep into this at the moment. And yeah, let's jump into the live demo. Let me see on my second screen if that all is visible. That looks good. All right, so when you go to geoBIM.app, and you guys can write me an email afterwards because I need your email address, and I put you on a whitelist, and you can just type in forgot password, and you get an email that lets you create a new password, and then you can link basically into my demo instance. Okay, so I do that now. And there we go. That's the start screen of geoBIM.app. It's Mother Earth. And on the left side, that's more or less the control center with the widget that you guys are going to be using in the future then. And so the first thing, it's the globe. There's a geolocator where you can jump to any address. You probably know that from Google Earth. So it's more or less the same philosophy. And the first thing I like to load is on the left side, you see a little widget that shows all the assets that I have made available for you guys. You can jump to all of those, and you just click on it and just import it. And in this case, it's probably a pretty well-known IFC file that I positioned at London City Airport. So let me zoom out quickly, and you will recognize this is London City Airport. Like there's the City of London, and of course there's a fly to button where I can just fly into that object or into that IFC file. So you see down here, there's a little widget showing what you can do with the asset. The first thing is to show you it keeps the metadata. I click onto that wall, it opens up a property box, and you can check what kind of IFC entity is and what other, let's say, metadata related information is available. So investigate by properties, and if you have the properties, how about, of course, filtering? So that's the first thing people would ask, like, can I switch off the walls? And yeah, of course you can. And you can already see that it is pretty fast. Switch off the standard walls, switch off the columns, and just jump into the building. And then what usually happens is that is kind of impressive, but what you're looking for is, can I save views, like bookmark views? And that's what people usually do. So I will probably save this view, then go on top. Maybe save this view, go to this side, save this view, and then you already know what happens. It creates, let's say, shortcuts to those views and jumps to those scenes. Okay. Good. Let me check for my little piece of paper here. So we had the info, we had the filter. So if we switch on everything again, filtering by property or IFC entity is cool. But I thought about, like, how about deleting or hiding things? Let's say we want to delete that wall, look into the spaces in here, maybe even delete that door. So you get the point. We can delete every single object from the scene in order to get access to data that we want to see. So that's the hide button. show all hidden. Right. So you would say, yeah, interesting. So that's kind of viewing technology, you know, from other web-based IFC viewers, clear. First thing we like to do is I show you a little bit of the layer management. So if I close the asset section here a little bit, you see a layer manager. Currently, you see Bing aerial maps. Let's switch that over to OpenStreetMaps. Takes a while to load, and then you have the whole scene with the map layer from OpenStreetMaps. And you can switch to Google Maps Contour. Let's do that. So it's a little bit of a different relief. And of course, you can switch on Google 3D tiles. So if you do that, you have the same scene using the Google 3D tiles. And that usually comes with the Ion account that I was recommending to use. And you see here a whole building in context with the Google 3D tiles. Now, let's wait a second. They take a while until they load because like America is waking up at the moment. But let's get the fragments here away. It would be just another IFC viewer if I couldn't just add another asset. And you all know probably this little BIM collab example that will pop up here in the upper right corner. And let's see, let's fly to that asset. And then you understand where the beauty is. So there's the second asset already here in this list. And we just directly fly into it. And if I move out here, see that this way, you can already see, oh, it overlaps with some existing buildings. And that's usually often the case. When I switch it off, you see that there's an existing building. And I'd like to position my design here. So what I implemented is a function that clips away the terrain. Let's go to, where is it? Measure and clip. And then you can take a rectangle or a polygon. Let's use the polygon. And it says use right mouse click to now define all the points. Let's move the view on the top and start here, 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 and roughly around the building. And you probably will assume what's happening. It cuts out the Google 3D tile mesh. And then we can just reactivate our building again. So this is how you would cut away existing build assets in order to position your own model here. Again, of course, this is a BIM object or an IFC object. If I click on this, it will open up the info tab. Now, how can I look inside an object? I think we have seen the filter option. We have seen the hide option. How about clipping planes? So for each asset that you have loaded, there's a clipping plane. Let me see. There we go. And we just switched them on. I just reversed them, and I know why. And then we start here. And let me quickly see if that works. Yeah, there we go. Okay, so it creates clipping planes around the bounding boxes of those assets. And I switched on the Z axis, and it cuts free the building. Okay. So this is what you usually would expect from your application. And of course, the same works in Y direction. Let's see. We have to go on this side. Yeah, here we go. It cuts off the building on the other axis. Let's go closer a little bit and cut through the building. And last but not least, let's do that for the X-axis as well. And start here right from this side. And cut the building. Of course, like all the three axes, you can do at the same time. That it's a little bit chaotic, but I think it works. So probably I have not tested this yet. Anyhow, I think you get the point. Clipping planes. All right. So that was that. So in a nutshell, first scenery that we created a new terminal building at the airport, and we created a new office building at the airport. One was greenfield, one was brownfield. Now, it would be, probably standard if you could measure within that model, but how about measuring the distance between the two? And I like to have a rough, let's say, measurement of the pathway, to the walk around from one office to the other. So we go to measurement tools and we say distance, and we go to this building, and let's say we are standing here, and we go this way and this way. Oh, there's a polygon, so there we go. Yeah, probably. So that's 800 meters. Obviously, it's not doing any polylines at this point, but who cares? Let's say we want to jump over there. Where is it? Here, and we fly over there. So it's probably 1.5 kilometers. And also, if you want to park your cars, you would probably say, I need sort of a space to park my cars and not the airplanes. Therefore, I would not use the measurement tool, but I would use the annotation tool saying, okay, let's create an area with the right mouse click, and we reserve some space for parking. And parking reserved. For company cars. So you create an annotation with a geometric primitive, which then is an object in space. It's georeferenced, and you can even fly to it. Let's switch that off. Go back to the office building, and you will know exactly what I mean. Let's go back to the office building. And we have seen the recent annotations. There's a list down here. It's all floating, and we can just click on one annotation and fly to the annotation, basically. Okay, and then, yeah, that's about it. Good. And then we like to, let's say, measure the area on top of here, because we want to have maybe a terrace up here. Again, we use the measure clip first, and we say measure, and then we say area, and then it will ask to left click the points, and we see how big is that space up here. And that's 150 square meters, and that should be sufficient to place a nice little terrace up here. Okay, so we have that. So what people always ask me is like, how can I pick coordinates? And when we say we have a BIM GIS application, you like to have coordinates for every point that you click on. And let's do that and just click that point and see what it brings. So it gives you the latitude and longitude on the ellipsoid. It gives you the height over the ellipsoid, which is 50 meters. It gives you the height over terrain. So basically, that was on the terrain. And we have to be careful now, because like the Google 3D tiles might not always be the same as normal Cesium World terrain in terms of height. So, but what I can show you is that 45 plus 481 is those 50.59. So the application will measure the difference, the so-called geoid undulation. And that's between the geoid and the ellipsoid, the difference. And that's 45 meters at this point in the Earth. So it's always different. I'll show you later again. Very important. To make things, let's say, a little bit more straightforward, I switch off the Google 3D tiles, because they look good from the distance, but are very inaccurate when you get closer. So I prefer to not work with them, but work with some digital terrain layers, some real ones. So switch back to Bing Aerial. And for example, if you like to measure now the height over terrain of a certain point, like this one, that's 5 meters. So this one will, in a perpendicular way, measure the distance to the underlying terrain. Let's do it from this corner. That's obviously 6 meters. Okay, I think you get the point. Good. And then, of course, you can save the measurements and just keep them in the memory as long as you want. They are persistent, stored in a database for later. So if I would open up the whole scene again, those measurement items would be still in there. Good. Let me check my script a little bit. I think that's it. So what we do now, we fly from London to Austria. And those of you who are using Revit probably know this example. We're going to be loading the architectural office. It was called Golden Nugget. That's in the Revit example files, and let's fly there. So we investigated 2 models coming from IFC, so more or less the open BIM approach. Close this. And then we go to the golden nugget, which is down here in the widget. We just fly there. And it's a larger model, and you will see the differences. And you will see already a problem that we seem to have. So obviously, we positioned that model in the wrong way, so too low compared to the terrain, okay? So the first thing we'd like to do is we just like to move the whole building up so it fits the Cesium world terrain in this case, okay? So what you realize is this is coming directly from the Revit importer. So there's a plugin in Revit, and it will take all the material textures as well, which makes it, of course, a little bit neater than the IFC files, who would potentially be able to transport material information as well, but it's not getting parsed usually. And you see this is a quite high fidelity model coming out of Revit. The same procedure here. Clipping planes, let's start with this. And let's move this over here a little bit and then switch this on. That's from the set access. That should work. There we go. It's probably a little, yeah, there we go. So it's a little bit speedy here on the left side. Of course, that works on Revit models as well. Cutting planes, pretty obvious. And then there's a specific Revit filter implemented in geoBIM.app. Of course, in the beginning, I didn't know if I should mix those two filters because, let's say, the properties are named differently. But of course, let's say you can switch off the walls here as well and look into the interior of the whole building. Then, to go even further and take away those elements, not by property sets, but by directly picking on them, you would probably say, okay, we take out the frame here, we take out the frame here, we take out the toilet installations here, and cut away the building, okay? So obviously the same technology as we used on the IFC files, but on a Revit model. Good. There we go. Annotations off. That's off. And there's visibility, the height mode off. Good. And there's a little bug. Obviously, it's not switching everything back on. No problem. We just delete the model again and just re-import it quickly. So there's the golden nugget, import it. And I like to hint you to another feature that can be easily being used in geoBIM.app. So there's the model again. And I'll show you later on why it's so low, because let's say Google 3D tiles in the Cesium world terrain have sort of a difference. And I think that's the undulation thing. But what I want to point you towards is, first of all, what usually happens is that you have OSM buildings. Switch off, switch on the OSM building. So in Germany, it's like comparable to CityGML. It basically represents all the buildings here in the city of Graz in a simplified LOD2 way. Those are having metadata as well. If you click onto them, it will give you probably the address, the altitude here, that's the street, that's the house number, and so on. But usually when you do a design, you want to get rid of those. So I switch off my design first, use the height function. Where is it? There we go. And shoot away the GML buildings, this one, and then place my building in here again. Okay. So what usually people ask, and I know that there's usually functionalities for shadow simulation in CAD programs and BIM programs, but I like to have that here web-based native because it gives you a good picture on the shadow simulation or the development of shadows over the time of day. Therefore, we go to the let's go lightning section, enable lightning, and you will see probably directly what happens. And there we go. It will create shadow effects. And in order to demonstrate this, I have to wait for you guys. There's a little bit of lagging. You can already see the shadows here, and I will be using, let me get rid of that. Yeah, there we go. That works. There we go. So I can use the slider down here in order to just move the sun around, and you see what happens here with the chairs. And if I zoom out a little bit, you will see that this effect is not only on the building itself, but on the surrounding buildings as well. So fairly easy to create some shadow simulation for any time in the day. If I go back a little bit, it also will, there we go, where is it? There it is. I think, yeah, here. a little bit of a sunset. It gives you a little bit the setting at night for the scenery. All right. So, and then some preset, of course, lighting situations. And it's interesting, of course, like the ray tracing, or let's say the shadow simulation, will also be visible in here with all the inventory and with all the furniture. Okay, so I think that's pretty neat in order to have a very quick overview and think about you can share that in the browser with your customers. I think that's a very good it's a very good way of showing how the lighting is affected by your building. Of course, that works on Google 3D tiles as well. Maybe if time's left later on, I will show that as well. Good. Let me see my script. Right, so that was for building design. How about other assets that are coming maybe from photogrammetry, reality data? And think about it, I always leave those assets here in these scenes. I don't delete anything or change projects. It's all one session in which I load different assets. So let's go to a bridge that was coming from photogrammetric reconstruction. So that means you take a drone, you do hundreds of pictures that are overlapping, and then CesiumIFC will convert those into reality measures or point clouds or Gaussian splats. That's what happened here. So I import it, and that takes a second. Should pop up here in a second. There we go. Asset is loaded. We fly to the bridge. And it opens up as a point cloud. Let me see on your side how that looks. It's obviously not there. There we go. And if I go closer, and the problem with point clouds is always, let's say, point size. So it looks very, very sparse usually. And you can see if I go closer that I activated attenuation, it's called. So that's the, let's say, distance dependent size of those points in the point cloud. And of course, there's a little bit of a segment where I can tweak this. Let's see if that works. There we go. That's the attenuation on, and it almost looks like a closed mesh, but if you go closer, you can see the points. So that's the as-is or as-built situation of that bridge in the desert here. And of course, it is possible to use that now for measuring purposes. So if I go to measure and clip, I can say, I don't know, there we go, measurement tools, distance from here to here. And since it's such a closed point cloud, it usually hits a point, so it's pretty accurate. And you can also use it for areas by saying, this click, this click, this click, this click, and measure on existing reality mesh data. Okay. The same works, and that is kind of a show effect, but just to show you that the clipping, let's say that the clipping on the asset itself works also on the point cloud. Let's go down here and say we want to clip. And I think then I have to switch all to the left and switch the X on. I think from this side. And let's see what happens if I switch that on. There we go. And you can basically activate the terrain by just sliding it in. Okay. Same works from this side. I think it's from the other side. There we go. It's a little bit fast. There we go. That's from the bottom. And of course, the same works from the X direction, which looks like this. Good. So clipping off. So what can you do with it? So usually the situation is in civil engineering, you have existing environment data, and you like to position your BIM project or civil project along that roadway here. Of course, I prepared already something, switched it off, and I think I called it RC Bridge. I'll tell later on why. And I will show you also in the end how to position those assets. So now you have the combination of, let's say we want to close the bridge on the right side. We need a temporary bridge to lead the traffic through the nearby, and we created a bridge. So again, that's a BIM model. Actually, I think it's even coming from Revit. No, it's IFC proxy elements. So I probably created it in Revit and exported it to IFC. And it shows you just simply that you can place any BIM object, BIM asset to a reality data object. Okay, no big deal. what I wanted to show here was with that bridge, two-span bridge, it's a plate, or let's say with reinforced or with reinforcement and pre-stress tendons. How can I make that visible? By either just making it transparent. Let's move that up a little bit, and then, oh, that's the point cloud. Sorry. Where is it? There's the bridge. There we go. And you can also see the reinforcement in that bridge. And in order to make it even more visible, I would probably hide the, where's the hide button? There's the hide button, chuck. And shoot away the reinforcement, the concrete on top. And you can see the tendons and the rebar reinforcement as well. Okay. So I think for the point cloud, it switched back to monochrome, and I can switch it back to the original RGB colors. There we go. Okay, so clearly very interesting to combine any CAD BIM object asset with any reality data object and asset. All right, last not least, maybe another little example for how to place designs into context, and especially for architects doing preliminary design and want to share that to the public as a public twin. It's pretty impressive. And I think that's what I usually use the Google 3D tiles mostly for. So I placed this Calatrava bridge in the middle of Dublin, and I still have the lighting on and the hide mode. So let's go to the bridge again, fly there. Switch the hide mode off. There we go. And again, you will see that, again, here the shadow simulation is still on. And I think here, if it's fast enough, I will switch from OSM buildings off, switch Google 3D tiles on, just to show you that, of course, the shadows also will prevail on the Google 3D tiles. Okay, so if I move out a little bit, let's do it like this. And then usually, probably have to switch on the lights again. It's not doing it at the moment. All right, that's typical presentation problem, I think, or it's at night. No, it's not. Or enable shadows, maybe. That could be a good hint. Yeah, obviously there's a bug in it, but anyhow, you will see that you can place the bridge here. Again, you would probably have to cut away the existing bridge that is here by just cutting it away. So what we do is measure and clip, take the clipping function, and in this case, I just clip from here to here and expand to here. You see what happens, and switch back on the bridge itself. I think pretty straightforward. All right, good. What else do I have? Yeah, just an outlook on what's going to be coming next. So I thought about, like, how about construction stages? So I created a little bit of an example called construction stages, and let's fly there. And I thought, like, why not use geoBIM.app as a kind of Synchro 4D kind of construction stage visualization for people on site. You can use that for various situations, and let's go to that bridge. So that's a real IFC bridge or real bridge project here in Germany. And I just placed it here at the Autobahn crossing or highway crossing in Germany. That's not the point for the moment. Again, if I click on it, you will see it's an IFC object, or asset, better to say. And what I did is I took the IFC file and open it in a kind of IFC editor, and I said, okay, we create a custom property called stage, and then we'll fill that custom property stage with the value 1, 2, 3, 4, 5, 6, so and so on, and assign it to different elements. That's what I did. And then geoBIM.app recognizes those properties and can create an animation out of it. How does that look like? We just create animation, and you'll see down here a little bit of a widget where I can start the animation that consists of 8 stages. Stage 1, 2, 3, 4, 5. And now you can see the difference. There's the existing bridge already in Google 3D tiles. And do we have still time? Yeah, we have 15 minutes left. Let me quickly show you how you precisely will cut out this bridge from the existing Google tiles and just position the bridge in that void. Measurement tools, where is it? The clipping tools, here we go. Now we want to have a polygon, and you can check it from here to here, to here, to here. Let's go all the way over here. That should be good enough for now. We cut out the existing bridge. We take away the filling. There we go. And we switch it back on. There's the bridge. And that the bridge is slightly too high, but we learned we can lower the bridge into its position. Then it looks like this. And then we start the animation again. There we go. Good, I think that's understood. Another last feature I wanted to show was how about linking built assets like reality meshes for operational purposes. Think about bridge inspection, bridge monitoring to external data. And I made an attempt to take a bridge in Belgium that was, I think, subject to a real investigation for bridge monitoring with IoT sensor data. And I found this bridge on Sketchfab, so it's available to everybody. And there's the situation. It's near Ghent in Belgium. It just takes a second until it loads, but it shows it's fairly large. There we go. Switch that off and switch that off. So you'll see it's a 3D mesh. Actually, it looks like a photogrammetry mesh, pretty accurate and dense. And I thought, okay, like how could that work to position an IoT sensor? And what I basically did is I just created a little object that should represent the sensor data. So it's just linked to the bridge. But the magic happens here is that Cesium is taking through Sensor Things API live data from an IoT sensor that runs on my server. Of course, it creates artificial data, but it's realistic data for a bridge in terms of accelerations, inclinations, temperature, and stuff like that. But it should show you that just in that session, we looked at BIM models for design and participation, but you can also use it for operational purposes, loading all your assets and connect them to any outside IoT sensor data and make that visible to everybody. Okay. Good. Let me see, is there anything else? Yeah, so for example, if that would be for operational purpose, that bridge we got to be taken care of. I wanted to show the last, let's say, functionality I thought for the use case of bridge inspection might be useful. So the annotation again, let's create an annotation saying, I don't know, let's take this one, okay. And we create an area with an annotation and return, and we say aberration, and then replace asphalt. And then we don't use the categories predominantly, but we say inspection comment, and we say there's a poor, let's say, situation on the superstructure. That's true. And it's corrosion. Let's call it corrosion or cracking or something other, and save it. And you will see in a second how that affects it. Let's go down to the under the bridge. And we see, I don't know where the green artifacts are coming from, so don't bother. Let's slide it back to it. Fly under the bridge. I think there's some graffiti under the bridge. I think over here. I think up here you see the graffiti on the upper left side. And let's create another primitive from here to here. And we say graffiti is graffiti double F or not? Yeah, it's probably double F. Clean, remove. And then we just say pure for the substructure, and it's some, I don't know, other again. And those, let's say, inspection items now get aggregated to an inspection report, which basically means it collects all the aggregated data from those annotations and is creating sort of an average rating for each component, for each, let's say, cluster in the bridge. It's a prototype event for bridge classification in terms of bridge inspection, very early stage, but I think very interesting to operators. And of course, that can be used to for any other structure where asset owners are operating it and need to inspect it. All right. Last example to show you what's possible in geoBIM.app. We fly to Atlanta. I think I showed this on LinkedIn already. It just should show you again what's possible. And let's go to Atlanta. And I will work not with BIM data now, but with GLB data, a format that is usually being used with designers or others. And let's switch that off. So that's the situation with Google 3D tiles in Atlanta. And I'd like to replace that Google 3D building with my own design, because that's pretty rough. If you go close, okay, so it's not very high resolution. So you know the game. I need to cut off the building first, or cut out the building first, by saying clipping manager on. Where is it? Measure and clip. And when we say rectangle, that's good enough. We say first point, second point, and then we just extend the rectangle with one stretch over here, which cuts this void, and then we replace our building. Okay. And then we have this nice little high resolution building. I think that was coming from Blender or anything else, with, you see the reflections in here, and it gives you a much better impression on how, let's say, maybe a refurbishment of that skyscraper would look like. And in order to see the difference between the quality between the first one and the second one, I implemented a little bit of a split screen view that shows you nothing on the left, or the existing structure on the left. Loads the Google 3D tiles one more, and let's go closer a little bit. So on the left, you see original Google 3D tiles. On the right, you see Google 3D tiles enhanced with my project in the middle. Okay. And let's be bold as a last functionality and check if the switch off this view. Let's check if the lightning works on the 3D tiles as well in Google. So let's switch to lightning on. Then we have to make sure that we are at the right time of the day. So it's in the middle of the night now in Atlanta. Let's switch down here. There we go. That looks good. And then enable shadows. Let's see what happens. Might take a second. No, it doesn't want. Anyhow, with that being said, the walkthrough geobim.app is over. I think you can get an idea of where the direction goes to and what's possible. I will build some more functionalities over the next coming weeks. Give me more. The more feedback I get, the more product value the whole application will get. Let's go quickly back to the slide deck. Let's see what's the next slide was. Yeah. So if you like that, if you wanna access the demo environment, write me an email to info@geobim.app. I can also help you with setting up an account with my colleagues from CesiumIon or from Cesium to set up your account. It's free of charge, and you can do whatever you want to do with it. It's a little bit commercial for smaller companies. You can use it as well commercially. If you want to use your own BIM models and data with geobim.app, just write me an email. We make it possible to create your own instance. And it's also possible that you build and operate your own geobim.app instance. Non-commercially, absolutely no deal, no big deal. If you want to run it commercially, just let's talk. And then feel free to clone my repository at github.com in order to get the code and build your own geobim.app branch. With that being said, I think it's 5 minutes to the hour. Thank you and have a great day. But I will stay here and look into the chat if I see any questions, and I would feel free to ask any questions. I have plenty of time, and yeah, thanks for listening for the moment. So let me up my chat box. There we go. Thanks, Derda. Any questions at that point? I'm surprised not to hear any requests for first-person mode or so. Let me switch off the screen sharing. There we go. And let me switch on the camera so you guys can at least see me. Let me switch on the chat. Where's the chat? There we go. All right, if there's not any more questions. Yeah, I mean, all I can say is just send me an email to info@geoBIM.app or write me a message in LinkedIn, and I put you on the whitelist, and you have immediate access to the DIM environment I was just using. Feel free to include or invite your colleagues and peers to use it. And as I said, the more feedback I get, the better the application will be. With that being said, have a great afternoon, have a great week, have a great weekend, and all the best until next time. Peace.